In this video, we're going to discuss how you can determine the rate of change of an exponential function, either the rate of growth or the rate of decay. We're going to use two different region questions to do this. Let's start with the rate of growth. This is question number 8 from the January 2016 Algebra 1 Regent. The equation A is equal to 1300 times 1.02 to the 7th is being used to calculate the amount of money in a savings account. What does 1.02 represent in this equation? So we know that all exponential growth equations are in the form A is equal to P times 1 plus R to the T, where A is the amount after T amount of time, P is the principal or the original amount, and R is the rate expressed as a decimal, and T is the time. So for this question, we want to know what is 1.02. And we know that 1.02 is what's in the parentheses, and what's in the parentheses in our original equation is 1 plus R. So we know 1 plus R is equal to 1.02. Now we want to solve this for R because we know that when we find R, we'll be able to see which of the answer choices is correct. Is this 0.2% decay, 0.02% decay, 0.02% growth, 2% decay, or 2% growth? So we're going to solve this for R for the rate. -1 and -1. R is equal to 0.02, which is the rate as a decimal. If we want to get this as a percent, we have to move the decimal place 2 places to the right, and this becomes 2%. And since we use the exponential growth equation, we know this is exponential growth, and the answer is choice 4. Let's say we had tried to answer this using the exponential decay equation. A is equal to P times 1 minus R to the T. And so whatever we have in the parentheses is 1 minus R, and we're going to set that equal to 1.02, and let's see what we get. -1 and -1. Negative R is equal to 0.02. And then we want to get R alone, so divide by -1, divide by -1. R is equal to negative 0.02. We can never have a negative rate, so we know automatically this cannot be exponential decay, and it has to be exponential growth. And in general, when you have something in your parentheses that's greater than 1, it represents exponential growth. When you have something in your parentheses that's less than 1, it represents exponential decay. So exponential growth could be the one in the question, 1.02. Exponential decay would be something like 0.78, which is less than 1, therefore it's exponential decay. Let's look at an exponential decay problem now. This is question number 28 from the June 2017 Algebra 1 Regent. The value v of t of a car depreciates according to the function v of t is equal to p times 0.85 to the t, where p is the purchase price of the car and t is the time in years since the car was purchased. State the percent the value of the car decreases by each year and justify your answer. So we know that this is exponential decay because in the parentheses we have a number that is less than 1. So we're going to write out our exponential decay function. Our exponential decay function is A is equal to P times 1 minus R to the T. And we want to know what the value of the car decreases by. We want to know what is the R, what is the rate. So we know that we have 1 minus R, and that is equal to whatever's in the parentheses over here, which is 0.85. And now all we have to do is solve for R. So -1 and -1. Minus R is equal to negative 0.15, and get R alone, divide by -1, divide by -1. R is equal to 0.15, and as a percent, that would be, we would move the decimal place 2 places to the right, and that would be 15%. That means that the value of the car decreases by 15% each year.